Electricity can be described as the flow of power or charge. Electricity is both a basic part of nature and one of the most widely used forms of energy. The electron is a subatomic particle whose electric charge is negative. It is not found on the nuclei of the atom, as protons or neutrons, and it was discovered in 1987 by Joseph John Thomson.
As a physical quantity, current is the rate at which charge flows past a point in a circuit. The current is simply the ratio of the quantity of charge and time. Voltage is a representation of the electric potential energy per unit charge. In other words, it is a measurement of the energy contained within an electric file or an electric circuit at a given point.
Resistance is the opposition that a substance offers to the flow of electric current. The standard unit of a resistance is the ohm, sometimes written out as the word and sometimes symbolized by the Greek letter omega.
A simple electrical circuit consists of three main elements: a current source wiring and an electrical load. The current source provides power, wiring carries power to the load, and the load uses the power. Electricity flows in a continuous loop from source to load and back again.
We know that a series circuit consists in two or more resistors connected one after another in a wire. And we can see this example in Christmas lights. To know the equivalent resistance, we need to sum all of the resistance of the circuit. And then for knowing the current, we need to know that the current is the same for all and it's equal in all points of the circuit. To take the current, we need to apply the Ohm's law, which says that the intensity of the current of a circuit is directly proportional to the potential difference, in this case the voltage, and inversely proportional to the resistance. And it will give us that the voltage is divided by each resistance. In this case, the current will be the same in all points. Then, for knowing the total voltage in a series circuit, we need to sum up the voltages of each resistance, and well, it will give us the potential difference. In a parallel circuit, this is the opposite. You need to use Ohm's law to get the voltage. You multiply the current by the resistance, and you will get the voltage or the potential difference, and it will be the same for each resistance of the circuit. To get the current, you need to have the sum of the currents, and it will give you the equal of total current of the circuit. To have the equivalent resistance, we should sum up all of the resistance and use the inverse. If in your house you have solar panels and you need voltage, then you need to connect these panels in a series circuit to gain more voltage. If you want more current, then you should connect them in a parallel connection.